Okay, so the first theorems that you see on your little worksheet are the Pythagorean identities. Okay, we're not going to play with those today. We will play with those on Monday, but hopefully they kind of look familiar to you. You guys remember the Pythagorean theorem is a squared plus b squared is equal to c squared. Okay, so you kind of see that relationship happening with these. You have these squareds. There's a 1 involved. But basically, when I see something squared, that's how I know something is using a Pythagorean identity. Okay, so we'll talk more about those later. We're going to use the reciprocal identities today, which you already know. That doesn't look new to you, does it? Nope, good. Okay, we're also going to use the quotient identities. And notice I said quotient rather than ratio identities. Our textbook uses quotient. I like the word quotient better too. This particular source that I got this from used ratio, but they're the same idea, right? Quotient is like a fraction. Okay, so remember that tangent is equal to sine over cosine, which makes sense, I hope, because remember that tangent in the last chapter was y over the x, and the sine was the y, and the x was the cosine. Remember that? Yeah. Perfect, good. Okay, and the cotangent is simply the reciprocal of that. Okay, we use a little bit of the even and odd identities, not a ton. Okay, those are usually really easy to identify because there's a negative in front of them. Okay, and then at the very bottom, you have cofunction identities. These are the exact same identities. One is just simply in terms of radians, the other one is in degrees. These are also super easy to identify because you see the sine or whatever trig function of that quantity of pi over 2 minus the x or whichever. Okay, those are super easy to identify. I like those. So, how the heck are we going to use this? Well, this is what we're going to do today. Okay, so I'm just going to do some examples. I'm just going to start with example number 1. Some of this is going to be incredibly easy, and some of it will be incredibly awesome. We're going to start with the more easy part today, and then the awesome part we'll do on Monday. It's, yeah. That's my code for harder. Okay, anyways. So all we're doing in this particular scenario is we're just finding the sine of the angle. So what am I looking for? Am I looking for the value of the angle? Am I looking for a ratio? I'm looking for a ratio. Okay, so if I'm given a cosecant and I'm asked to find a sine, what is the relationship between the two functions? They're what's? Getting closer. Reciprocals of each other. That's the right word, reciprocals. Okay, so you guys know that if they're reciprocals, then what will the sine ratio be? Nailed it. Yeah, so you just flip it, right? So it'd just be 4/7. Boom. Nailed it. Easy peasy. That was so easy. Ha! Not all we're doing. We have to make it a little bit more cool. Okay, so now this one they give to us, I don't like the way they give it to it, but I'll just use it as an example. Don't you have to do something? Yeah, I'm not going to do a whole bunch. Okay, so for this particular example, they give me 2 pieces of information. Okay, so I'm given a cotangent and I'm given a sine, and I'm asked to figure out what the cosine is. So again, I'm looking for a ratio. Can somebody give me a relationship that involves cotangent, a sine, and a cosine? Okay, so everybody looking at the quotient identity on their sheet. Okay, you should be looking at the one that says the cotangent of the angle is equal to cosine over sine. Okay, so that's what I'm going to use. All I'm going to do is simply replace the fractions or the ratios with their equivalent values. Okay, so cotangent is given to us as 2 over 5 square roots of 5. We don't know what cosine is quite yet, so we're going to just replace it with a cosine. And then the sine is given to us as a square root of 5 over 3. Okay, so all I'm going to do is just solve for the cosine piece. Okay, so if I'm dividing by a fraction, what's the first thing that you would do? Multiply by the reciprocal. That's true if I want to keep it on that side. But if I want to send it to the other side, what am I going to do? Yeah, I'm just going to multiply it to the other side. So that's kind of a tricky piece because you feel like you need to reciprocate it, but don't reciprocate it. Okay? Because it's technically is being divided. Okay, so now I can simplify a little bit. What do you notice cancels out? The square roots cancel out, right? Square root of 5s. So I'm left with 2 over 15, and that is equal to the cosine of the angle. Boom. Not too bad? Keep going. Let's do number 3. So let's say they give us a cosecant of 25/7. Wow, that was a bad 7. Let me redraw that. 25/7. And a secant of 25/24. And ask us to find the tangent. Okay. All right. Now this one is going to require a little bit more playing. Let's say, okay, does anybody see a relationship that involves a cosecant, a secant, and a tangent? No, there is not one on your identity sheet. Okay, is there a tangent identity that could involve something that we could do with a cosecant and a secant? Okay, so if tangent is equal to a sine over cosine, could we somehow manipulate the cosecant and the given secants so that we can use those? Okay, so we can immediately say that if we are given cosecant, what do we know? The sine is what? 7/25. Good. And if they give us a secant, we know what? The cosine is 24/25. Good. Okay, so now we're going to use the identity, the quotient identity, that the tangent is equal to the sine over the cosine. Okay, and if I fill in those ratios, the sine is 7/25. Now I know I'm going to divide by a fraction. Is everybody following with me? If I know I'm going to divide by a fraction, I'm going to multiply by its reciprocal on the right-hand side. Is everybody okay with that? So I'm going to say 7/25 times, since I'm dividing by 24/25, that's the same as multiplying by 25/24. Everybody follow that? Okay, so what cancels out? 25s, so it's my tangent ratio, 7/24. What do you guys think? Pretty easy, right? That's kind of cool. It's kind of fun to play with these. At least I think so. That's just all we're going to do for today.
Really?
Yeah, because I'm going to save the rest of it for Monday. And, let's see. We're on 3:17. And I even thought about this already, but I forgot what I wrote. Hold on. Wait for it. There we go. 2 through 20 evens. That's it for today.